So let us now discuss sample problem number 1. So a reinforced concrete column of a multi-story concrete frame building has a dimension of 450 by 40 by 450 mm. So with a clear height of 4 meter. So etong clear height na to, that is denoted by L sub U. Kasi clear height, so kapag clear height, so that is yung unbraced length natin na 4 meter. The frame is effectively braced against swing. So naka-brace tayo against side swing by stair and elevator shafts having concrete walls that are monolithic with the floors. The structure will be subjected to vertical loads and live loads as follow. So meron tayo ditong mga unfactored loads. So sa actual load, meron tayong dead load na 1026. Meron tayong live load na 770. Sa top moment naman, meron tayong positive na unfactored moment na 2.72 kN/m. Sa live load naman, meron tayong 147. Sa bottom moment naman, meron tayong negative 2.72. Sa live load naman is 137 kN/m. So the column is subjected. So single curvature lang tayo. Use F'(C) which is equal to 27.6 megapascal. The value of your Fy which is equal to 414.70. Determine the magnified design moment. So hanapin daw natin yung magnified design moment which is denoted by M sub C. So that is equal to the magnification factor multiplied by the bigger moment natin which is denoted by M sub 2. So for that, para malaman natin yung magnified moment, siyempre tingnan muna natin kung may effect ba talaga yung slenderness dun sa column natin. So to check for that, so we will going to solve first yung slenderness ratio natin. So, meron tayo ditong columns, brace, against, side sway. As indicated dun sa problem natin. So, with that, yung gagamitin nating criteria para malaman natin kung short or long column ba tayo. So, we will going to compare yung slenderness ratio to this value na 34 plus 12 multiplied by M1 over M2. So for this one, hanapin muna natin yung value ng M sub 1 natin at saka yung value ng M sub 2 natin. So first, ito yung M sub 1 natin. So gagamitin lang natin yung mga given natin na unfactored loads and i-apply natin yung 1.2 dead load plus 1.6 live load. So 1.2, yung dead load natin, that is negative 2.72 plus 1.6. So ito yan sa bottom moment, 137 o yung 136. So 136 pala to. So you will have a value of your M sub 1 which is equal to 214.34 kN/m. Next naman, let's compute for the value of your M sub 2, which is the top moment. 1.2 dead load na positive 2.72 plus 1.6 na live load, which is equal to 147. So you will have a value of 238.46 kN/m. So, kung pag-compare natin yung dalawa, hamak na mas mataas yung M sub 2 natin to the value of your M sub 1. So, yung bigger moment natin, that is designated by M sub 2. While on the other hand naman, yung smaller moment natin, that is designated by M sub 1. So, for this one, check natin yung M sub 2 natin. Kung greater than ba yan dun sa value natin sa M sub 2 minimum. So, meron tayong value ng minimum natin for M sub 2 So we will going to use this formula na yung factored actual load natin multiply by 15 plus 0.03 multiply by age. So for that, meron tayong value ng age natin that will be the height nung column natin, which is given naman na 450 mm. So yung PU na lang yung hahanapin natin. So the value of your PU. So ito yung factored actual load. So from the definition of factored actual load, titingin lang tayo sa actual load natin. So 1.2 dead load na 1,026 plus 1.6 live load na 717 kilonewton. So we have a value of your piece of U which is equal to 2,463.20 kilonewton. And after we calculate for the value of your piece of U, we can now calculate for the value of your M2 minimum. So what will be the value of your M2 minimum? So substitute natin yung mga values natin. M2 minimum is equals to 2,463.20 kilonewton multiplied by 15 plus 0.03, yung H natin that is equal to 0.45 meter. So you have a value of your M sub 2 minimum which is equal to 36.98 kilonewton, which is less than dun sa value natin na M sub 2. So ano yung M sub 2 natin dito? Okay, na 238.46 kilonewton. So, ito yung a-adapt natin. Therefore, okay. Kasi minimum lang naman yung value natin eh. So, yung minimum value ng M sub 2 natin, dapat hindi siya bababa sa 36.98 kilonewton. So, nakuha na natin yung value ng M sub 1 natin. Nakuha na natin yung value ng M sub 2 natin. Na-check na natin kung yung M sub 2 ba natin is lalagpas ba siya or hindi lalagpas sa value ng minimum value. So, we can now calculate. So, we can now calculate kung long column ba or short column ba yung column natin. So, with that, so yung K natin na given dito, that is 1.0. Yung LU natin na given, that is yung length natin na unbraced length na 4 meter or 4,000 mm over yung R natin since square column tayo, so that is 0.3 multiply by H. So 0.3 multiply natin sa H. Kasi square column, kapag naman circular column, that is 0.25 H. So yung H natin dito, that is equal to 415. So, i-compare natin yan to the value. Of 34 plus 12 multiply by, so yung M sub 1 natin, so that is 214.34. Yung M sub 2 natin, that is 238.46. So, for this one, since sinabi is single curvature, so kapag single curvature, yung column natin is buntis. So mangyayari, yung value ng M sub 1 over M sub 2, that is negative. So kunin natin yung mga values nila. So yung KLU over R natin, that is 29.23. Ito naman, this is equal to 23.21. Since greater than yung value ng slenderness ratio natin, therefore, slender yung column natin. We will going to consider yung slenderness effect dun sa column natin. So, after natin ma-compute na slender yung column natin, let us now solve for the value of your magnified moment. So, if we will going to go back with that, so that is, so since slender yung column, so, yung magnified moment natin, that is yung magnification factor multiply by M sub 2. So ngayon yung problema na lang is what will be the value of your magnification factor. So yung formula ng magnification factor, that is equal to C sub m over 1 minus P over 0.70 of P sub C, which is greater than or equal to 1.0. Next naman, in computing for the value of your C sub m, since wala naman tayong sinabi dito na without lateral loads naman tayo, so yung C sub m natin, that will be 0.16 minus 0.14 so m sub 1 over m sub 2. So let's compute for the value of your C sub m. So that is equal to 0.16 minus 0.14. So since single curvature rin tayo, yung ratio ng m1 over m2 natin, that will be negative over 238.46. So the value of your C sub m will now equal to 0.96. After we calculate for the value of your C sub m, so nakuha natin yung value ng C sub m, meron na tayong value ng P sub u natin. Let us now calculate for the value of your critical buckling load. So para makuha natin yung critical buckling load natin, so that is pi squared multiplied by EI or yung flexural rigidity natin over yung effective length natin. So ito yung effective length natin, which is denoted by KL sub U squared. So yung problema lang natin dito is what will be the value of your EI or yung flexural rigidity natin. So by formula, so gagamitin natin is 0.4 EC IG o yung gross inertia over 1 plus yung creep factor natin. So madali lang naman yung pagkuha ng modulus of elasticity at saka yung IG natin o yung gross inertia natin. So magkakaroon lang tayo ng problema dito sa creep factor natin. So in computing for the value of your creep factor, which is denoted by beta sub DNS, so that is equal to factored sustained axial dead load. So yung axial dead load lang natin na naka-factor. So yung axial dead load natin, that is 1,026 over yung total axial factored load. So over yung total axial factor load natin, which is eto, na 2,463.20. So yung value ng creep factor natin, that is equal to 0.15. So kung meron tayong value ng creep factor, we can now calculate for the value of your flexural rigidity effective, which is equal to 0.14. Yung modulus of elasticity ng concrete natin, which is equal to 4,700 multiplied by 1.7 square root of f prime c natin na 27.16 multiplied by yung gross inertia natin, so that is BH cubed over 12 over 1 plus yung creep factor natin, which is equal to 0.15. So the value of your flexural rigidity na effective, that is equal to 22,500.38 times 10 raised to 9 Newton mm squared. So after we calculate for the value of your IE effective, we can now calculate for the value of your critical load. So let us now solve for the value of your critical load. So that is equal to P sub C is equals to pi squared. So yun na-compute natin na EI effective, which is equal to 22,500.38 times 10 raised to 9. So sa paggamit natin ng mga formula, dapat naka-Newton at saka naka-mm tayo. Over, So, meron tayo dito yung K natin na 1.0, yung unbraced length natin na 4,000 mm squared. So, the value of your critical buckling load is equal to 13,879.37 kilonewton. So, after we calculate for the value of your P sub C, we can now calculate for the value of your magnifying factor or magnification factor. So, yung C sub M natin, that is equal to 0.96 over 1 minus yung PU natin, which is equal to 2,463.20 over 0.75 of P sub C natin na 13,879.37. So that is equal to 1.26, which is greater than 1.0. Therefore, okay. So after natin makuha yung magnification factor, so that will be yung magnification factor multiplied by the bigger moment. So we have 1.26 multiplied by m sub 2 na 238.46. So you will have a value of your magnified moment which is equal to 300.46 kilonewton meter. So this will be your answer. So ganun lang yung mga procedure natin in computing for the value of your magnified moment.